Today we are continuing with bipolar junction transistor. Today we will discuss about the introductory concept of the bipolar junction transistor, modes of operation, transistor configurations, transistor action, that means current conduction mechanism, BJT current gain alpha and beta, Ebers Moll model in transistor, common emitter configuration, common base configuration, common collector configuration, comparison of transistor configurations. Now regarding the name transistor, where from it has come, it is the transfer of resistor. The transfer of resistor means there are few sections in the transistor in which the resistances are not same, because transistor is made up of three pieces of semiconductor. One piece is called emitter, another is base, and the last one is collector. All these three pieces of semiconductor are joined to form two number of junctions called EBJ and CBJ. EBJ stands for emitter base junction, CBJ stands for collector base junction. Now in this three terminal device, the width as well as doping concentration of all these regions are different. Emitter is highly doped, that is why the resistance is lowest for the emitter part of the transistor. The base is thin as well as lightly doped, and the collector has moderately doped as well as the widest area in the transistor. There are another type of transistor which is known as the field effect transistor. So what is the difference between BJT and FET? BJT is a current control device, whereas FET is a voltage control device. So we will come to FET later on. Now we are continuing our discussion with BJT. As the current, which is the main control signal for the BJT, therefore varying the impedances in various sections, the amount of charge carrier flow may be controlled by applying external voltage. So since EBJ and CBJ, there are two junctions, we can control the biasing voltage, that means applying the voltage to this junction, making them either forward bias or reverse bias. We can control the amount of current flow, and therefore we can get various advantages or various modes of operation through BJT. Now transistor has two PN junction. The structure of PNP and NPN in sequence called emitter, base and collector as shown on the right hand side. They have symbolical difference to understand whether it is NPN or PNP transistor. The doping concentration, as we already have told, that emitter is having a high doping concentration, base is having low doping concentration, and the collector is having moderate doping concentration. The size of the emitter is moderate, base is thin, and the collector is the widest area. The two number of PN junction which can be biased differently, that means sometimes EBJ is forward biased and CBJ is reverse biased. This type of operation forms a mode of operation known as the active mode of operation for the transistor. Another mode of operation is the saturation mode, in which EBJ and CBJ both are forward biased. There is another mode of operation which is called cutoff, in which EBJ and CBJ both are reverse biased. So therefore, applying external potential, this EBJ and CBJ may be forward biased or reverse biased, so that the flow of charge carrier through the junction may be controlled for the type of operation which we require. The operation that is called the active mode of operation is responsible for amplification of the input signal. Sometimes saturation and cutoff mode are also used for the switching operation using transistor. Switching operation is very much important in digital communication, in which frequently we are transmitting either logic 0 or logic 1. So therefore logic 0 stands for off condition, that is the cutoff condition, and logic 1 stands for the on condition or saturation condition. Depending on the type of connection, there are three number of transistor configuration. They are common emitter, common base and common collector. Now why such name is given common? because common stands for a particular terminal when it is common to the input as well as output section. Such as in case of common emitter configuration, the base and emitter forms the input terminal and the collector and emitter forms the output terminal. So therefore emitter is common to both input as well as output side. Similarly, for the common base configuration, base is common to the input and output section, in which emitter plays the input terminal role and collector plays the output terminal role. In case of common collector, base is the input terminal and collector is the and the emitter is the output terminal. So in this way, the three configurations are used depending on various types of requirement, such as the input impedance, output impedance, all these things, such as the common collector configuration is having high input impedance and low output impedance. That is why common collector is very much essential for the type of operation in which impedance matching is required. The voltage gain of the common collector is unity. The large amount of current gain and power gain is also achieved using common collector configuration. It is used as a buffer or connection of another amplifier to a low resistance load, because common collector is having low output impedance. That is why low resistance load may be handled using common collector configuration. The common base configuration has low input impedance and high output impedance. Therefore, for the current amplification, common base configuration is very much useful. The common emitter configuration has moderate input and output impedance. So moderate voltage and current and power gain may be used using common emitter configuration. Regarding the transistor action, we need first the complete knowledge of the current conduction mechanism, because until and unless the current conduction mechanism is clear for a bipolar junction transistor, none of the operation using transistor will be clear. So before going to start the current conduction mechanism, let us start with the two number of junction, that is there are emitter based junction and collector based junction. This emitter based junction, if forward biased, then emitter emits huge amount of electrons. We are considering NPN transistor, that is why electrons will be emitted by the emitter, and these emitted electrons are entering into the base region, which is thin as well as lightly doped. So there is no sufficient number of hole which can recombine with the emitted electron. Therefore little amount of hole may recombine, which will form the base current, and the remaining electrons, which are minority carrier in the base region, will be increasing the density of electron or increasing the density of minority charge carrier in the base region. Under these circumstances, if the collector base junction is reverse biased, that means if collector terminal is applied with positive voltage, then these electrons will be attracted towards the collector terminal. Therefore we can easily collect these electrons, excess electrons residing in the base region, to form the collector current. Now under this situation, there are minority charge carriers residing in the collector region or holes. So since collector terminal is applied with positive voltage, therefore the holes residing in the collector region as minority carrier will be repelled by the collector terminal and they will be entering into the base region. And since base region is applied with negative voltage, therefore holes from the collector region will be entering into the base region towards the battery terminal. So we are talking about the battery which is reverse biasing the collector base junction. Therefore minority charge carrier hole will be entering into the base region due to the negative voltage applied to the base region. Similarly, there are minority charge carrier electrons residing in the base region will be attracted to the collector terminal due to the positive terminal battery is connected to the collector terminal. So these minority charge carriers crossing the junction forms a leakage current, which is a little amount of current and unidirectional. The direction of the leakage current flows from collector to base region. So therefore, along with the primary collector current, this leakage current is also present with little amount, which is required to be considered as this leakage current is very much temperature dependent, because more is the temperature, such generation of the minority charge carrier will be increasing. Therefore, leakage current plays important role when there is a temperature variation in the surrounding area of a particular electronic device. So this transistor action is continued to the next slide, in which the leakage current has been described, and it has to be noticed that ICOP stands for the collector leakage current due to holes when the input terminals are open. Similarly, collector leakage current due to electron when the input terminals are open is known as ICON. The BJT current gain bipolar junction transistor is having the current gain are of two types. One is the alpha, another is the beta. To discuss this part of the slide, we should understand, or we should have a common knowledge regarding the nodal current equation of this transistor. That means there are three branch currents. One is the base current, another is the collector current, and the emitter current. So what is the algebraic relation of this current? According to the direction, the emitter current is moving away from the terminal because it is a NPN transistor. But the collector and base current are entering into the transistor. So therefore, the summation of collector and base current must be equal to emitter current. And the ratio of the collector to emitter current is known as the alpha current gain, which is practically unity. And the current gain due to the collector current by base current is known as the beta current gain. This is much larger compared to 1 because base current is very small compared to collector current. For example, base current is of the order of microampere, whereas the collector current is of the order of milliampere. So milli by micro is a 1000 relation. That means 1000 comes due to the ratio of the milli and micro. And these ratios are similar even for increments, that is beta AC equal to beta DC. So beta current gain is normally practically it is varying from 50 to 200, and beta is equal to alpha by 1 minus alpha, alpha equal to beta by 1 plus beta are the important relation which will be required for mathematical problem solutions. Now, one of the important model to describe the operation of the transistor is known as the Ebers-Moll model. In the Eversmall model, we can visualize two number of diodes which are equivalent to the EBJ and CBJ junction diode. So in case of EBJ, emitter is N type and the base is P type. That is why the diode direction is from base towards the emitter. Similarly, for the CBJ diode, collector is the N side and the base is the P side. Therefore, this is another PN junction diode. There is a common question asked in almost every interview that if there is a back-to-back connection of the diode is made in the laboratory, whether it is equivalent to a transistor. The answer is no. The back-to-back connection of a diode of two number of diodes will not form transistor, because the transistor are having the semiconductor regions are of varying width as well as varying doping concentrations. But whereas the normal diode are not having special type of width as well as doping concentration variation. Therefore, such a back-to-back connection of the diode will not be the equivalent operation of a transistor. But though there is a PN junction exist in the transistor, one is the EBJ and CBJ. So Ebers-Moll shows an equivalent symbolic representation of the transistor by connecting back-to-back diode. Remember, it is symbolical representation, it is not the practical diode condition, because EBJ and CBJ are PN junction, that is why it is represented by diode connection. So when the EBJ junction is forward biased, at that time there is a current which is flowing through the collector is alpha times emitter current. That is why this type of current is known as the forward active operation, in which alpha F is the forward active gain, current gain. Similarly, alpha R is the reverse active mode, in which we are getting the current gain alpha R, which is much smaller compared to alpha F, under the reverse active mode in which EBJ junction is reverse biased and CBJ is forward biased. So under this, why alpha R is not dominating over alpha F? Because when the CBJ is forward biased, at that time collector emits electron, and since the doping concentration of collector is much less compared to emitter, therefore EBJ produces more current, more charge carrier generation due to the forward bias of EBJ compared to when the CBJ is forward biased. So collector emits much less number of electron. That is why alpha R current gain is very less. If we look at into the two number of models of a transistor, that means NPN and PNP, we can get the equivalent model for the Eversmall configuration, and there are current equations. IE is equal to IE0 e to the power VB by VT minus 1 minus alpha R into IC0 into e to the power VCB by VT minus 1. Collector current is equal to minus alpha F IE0 VEB by VT minus 1 plus IC0 into e to the power VCB by VT minus 1. Now remember, this Eversmall model is the symbolical or diagrammatic description of the transistor, in which the current flow may be divided into two mode of operation. One is the forward active mode, another is the reverse active mode. So depending on the type of the diode switched on, we can keep the diode as short circuit, and if the diode is off, we can replace the diode by open circuit, and thereby we can explain the circuit operation using the formula of the circuit theory. So therefore Eversmall model help us to find out solution for transistor if we are interested to build the equation in terms of the circuit theory model. Now this is the common emitter configuration. In the common emitter configuration, as we have discussed, that the emitter is the common terminal for the input and output section. Now the base emitter junction is forward biased and collector emitter junction is reverse biased. Now as the base emitter junction is forward biased, therefore base current flows, and corresponding emitter emits electron, and those electrons are collected by the collector, therefore collector current is also formed. So these are the DC currents which are available due to the biasing of the base emitter junction as forward biased, and collector junction is the reverse bias. So therefore what we are getting, there are two number of characteristics can be obtained under this configuration. One is called the input characteristics, another is the output characteristics. For the input, it is between the base emitter voltage and the base current. So base emitter voltage is increased. Initially there is no considerable base current can be obtained, but after certain amount of base emitter voltage, the base of the order of fraction of 0.6 volts, we are getting the current is starting to rise. That means the base current will be increasing in microampere, in the range of microampere. So when the collector emitter voltage is fixed at 20 volt, large amount of base emitter is required to get the current, and if the collector emitter voltage is reduced, that means if it is 10 volt or more reduced to 0 volt, at the same base emitter voltage we can get more amount of base current. So this is happening for common emitter configuration under the input characteristics. For the output characteristics, if we change the collector emitter voltage, we will get the collector current, and for this characteristics base current is kept constant. So if the base current is 0, means there is no base current, so it is almost cut off. If the base current is increased to 20 microampere, then initially the collector emitter voltage is increased, and gradually we are getting linear increase of the collector current. So initially it is a ohmic region, and thereafter it is reaching the saturation, after which the collector current is becoming constant. So we should remember that for every characteristics of this collector emitter voltage versus collector current, our base current required to be fixed. That means either 20 microampere or 40 microampere or 60 microampere. In this way, base current is required to be fixed. There are two important parameters which are called input resistance and output resistance. So dynamic input resistance means change in base emitter voltage by change in base current. This ratio is known as the dynamic input resistance. Similarly, dynamic output resistance R0 is the ratio of the change in collector emitter voltage to the